Hello, my name is Cameron Rickard, and this is the Pearson and Lyons Greenboard assignment, mapping the new commercial landscape, where I focus on management and new technologies. This presentation is for Engineering Management 500, taught by Professor John Gillis. Here's the agenda for the presentation. We'll first look at the overview of management and new technology predictions made by Pearson and Lyons, along with key points, and then move on to briefly defining what manufacturing operations management is and some of the tools that are used for the welding process. And within those welding processes, we'll look at the adaptive welding software for solid state resistance welding and arc monitoring software for arc transfer welding. These are data and monitoring software for the welding process. And then we will discuss what I believe welding technology will look like in 10 years and a brief summary and references at the end. So within their writing for management and new technologies, they predicted over the next 10 years, new management systems will offer greater and more timely information on the performance of every aspect of company, supplier, customer operations, but managers will have to learn how to best use them. They also predicted that these systems will offer an unparalleled opportunity for employers to monitor and control every aspect of employees' work life with a danger of a big brother micromanagement. They also predicted that companies will give greater autonomy to employees by enabling the sharing of ideas among and between teams and by ensuring that information on both company and its environment is available to all who need it. This is evident at Fiat Chrysler. Every piece of information and data is available to shop floor management, mid-management, so their predictions here are pretty spot on so far. So the next section is actually fairly spot on as well. They say those seeking to impose a uniform process on individuals with an emphasis on monitoring compliance and performance may well increase short-term productivity, but in doing so, they will reduce diversity, undermine trust, and restrict experimentation. One way Chrysler kind of combats that experimentation restriction is to tell employees, and they encourage employees to put in suggestions and create kaizens, work with middle managers and supervisors that create those kaizens. But the problem, again, is not the technology itself, but rather how it's used. And they say the choice between controlling workers on one hand and enabling them to innovate and cooperate on the other is the modern day equivalent of battle between scientific management and human relations school. 3 key points I took from their writing was the impact of management monitoring systems at cause and effect, and how it may reduce experimentation, but also on the one hand constrict and tighten up the whole process of manufacturing. The other one is the accessibility of information to all team members, which Chrysler provides to all members of the team, either through visual representation, public information, emails, and then also the big brother effect on how all this information is used. Manufacturing operation management, in short, is a type of methodology or tools that an organization uses to enable the viewing of various manufacturing processes and data with the goal to optimize the efficiency. The welding industry has made some pretty groundbreaking technological advances that management is now using in their favor to collect data and improve their welding process. They're using digitally controlled welding systems that can collect that and track that data while producing instantaneous feedback without human intervention. So for the solid state resistance welding, it utilizes an adaptive control to precisely adjust welding parameters in real time, so every weld is performed within the tightest quality tolerance. And much like the solid state arc transfer, such as MIG welding, utilizes that arc to monitor and adapt the welding process to various joint geometry changes. This is a look at adaptive welding software that's used for solid state welding, such as spot welding or resistance welding. So it'll take the analysis from the weld nugget and the tooling and the whole process and put it in an algorithm and make instantaneous changes to the current and weld time to recover from any disturbance. It'll also look at the weld nugget that's produced and refer it to an actual reference weld nugget. It can also give feedback on if the tooling is in need of maintenance and it's starting to wear, and it can also identify other process changes that need to be further investigated. This is arc monitoring software for that arc transfer welding process, such as a MIG welding. And unlike adaptive welding, which is instantaneous and very quick and efficient, the arc monitoring software actually takes a little bit more time and slows down throughput, because as you can see in the flow chart, it scans the weld joint first, then it analyzes and then makes any adjustments to the path or current, wire feed speed, and then it'll come back to the start of the weld and create that weld. So it actually takes a little bit more time, but it does produce more quality welds and less scrap. And in the next 10 years, I predict that due to the weld management software, there will be a decrease in the demand for weld technicians, and the weld technicians that are actually on the field will be more focused on the maintenance rather than the welding process. And for maintenance, I would imagine that they would be more proactive and hopefully not reactive, because they are given a lot of valuable data through this adaptive and arc monitoring weld management software. And also safety industry-wide, I believe it'll be less of an issue due to less metal finishing, and the overall line efficiency industry-wide will also increase. In summary, manufacturing operations management methodology and tools to track data and monitor data can help improve the efficiency of all organizational assets. And when implemented in a welding process, it can instantly make adjustments and take human error out of the equation. And in the next 10 years, both solid state welding and arc transfer welding processes will be free of human adjustments, in my mind. Now, these are just some of the references used to produce this presentation. Thank you for watching.